We will be factoring still in this unit, and I know that wasn't the greatest for a few of you in here still. Okay, so if you need factoring practice, please come in and get extra help from me, all right? Because I'm not going to review how to do it, but you are going to have to still factor in this unit. All right, let's start it off here. Last unit, our similar triangles unit. We solve proportions, a ton of them. All right, we solve proportions. And one day during this unit, I said, hey, you know something? When you multiply these two in a proportion, those actually have names, right? They actually have names. These were called the extremes, and these were called the means. And we had a little theorem that said, hey, the product of the means equals product of the extremes. What I want to show you right off the bat today is a special type of proportion. Okay, a special type of proportion when the means are the same. All right, the means are the same. So if I go A over B equals B over C, this is a special type of proportion. Does everyone see the means are the same? It's called a mean proportional. All right, so when the means are the same, we refer to them as a mean proportional. All right, so the numbers are the same, might be variables are the same, but whatever's in the mean spot is exactly the same. We call this a mean proportional. And the extremes are always different. So right off the bat here, I want to make a proportion where you guys find these values. I want you to find these values when the other two values are 4 and 16. So we'll start off with our proportion. And since they tell me it's a mean proportional, I know the means are the same. I just don't know what they are. You're going to help me find it out. And then the extremes now are going to be 4 and 16. So we're cross multiplying. We get x squared equal to 64. And hopefully everyone's good. Take the square root from here. And I know most of us are just plopping down x equals 8, right? Well, I'm going to have to come around to everybody's paper and throw a little -1 on there. That's not fully correct. 8 is not fully correct. Any takers why? It's part of it, part of the answer, but not full credit. When you take the square root of a number, you're left with the positive version and the negative version. So we got to write both down. So this is going to be plus or -8. And it makes sense too. Hey, doesn't it make sense? If I plug in -8 here and -8 here and you cross multiply, you're going to get positive 64. All right, so that's why I do need both versions in. All right, the positive and negative version. Questions on what a mean proportional is? Because we're going to be setting up mean proportionals all day today and tomorrow. This is a 2-day topic. All right, so I want to introduce you to a special diagram and see what you guys can tell me about it. Can you first start me out with a right triangle, please? A right triangle. Because that's what this whole unit is dealing with, right triangles. And let's be creative. Why don't we call this right triangle ABC, where A is the right angle? And then from here, I'd like you to draw, starting from the right angle, angle A, I'd like you to draw, I'm going to use a vocab word here. I'm drawing altitude over to the hypotenuse BC. And call that point D on the hypotenuse. An altitude. I didn't put these on here because I want you to. You should be able to put some other markings on your diagram if you know that as an altitude. Oh boy. It's an altitude. What other markings can I put on my diagram if I know AD is an altitude? Talk to me here. More calling on people this semester. Zoe, what an altitude does what? both sides are going to be a right angle. All right, so that's what we should have on our diagram. Now, in this entire diagram, how many triangles do you see, including the original one we drew? Everyone sees 3, right? Everyone sees 3. So instead of naming them by their letters and wasting some time, I'm going to call this triangle 1. I'm going to call this triangle 2. And I'm going to call the big one triangle 3. And we're going to find out something about these 3. So let's start here. Can everyone look at triangle 1 and the big one, 3? Look at those 2 triangles for me. They both have what type of angles in them? 1 and 3, they both have right angles. And we know right angles are congruent. Next, they also share an angle. A full angle they share. Triangle 1 and triangle 3 both share which full angle? Angle B. All right, so this is what we got right now. And we're going to put this together. They both have right angles. They're congruent. They both have angle B in common. And we know by reflexive, that's congruent. So they have 2 pairs of angles. Let me say that again. Two pairs of angles congruent to each other. What do I know about those 2 triangles? They have to be similar. Nice! From last unit. So right now, we just proved that triangle 1 is similar to triangle 3. All good. Moving on. Can you now look at triangle 2 and triangle 3? Triangle 2 and the big one. They both have what type of angles in them? Right. Woo! Right angles are all congruent. And they share which full angle? C. Right? They all share C. Let's put that together. Right angles are congruent, and they both have a reflexive angle C, which we know is congruent to itself. What do we know about triangle 2 and the big one? They also are similar by angle. So now we have triangle 2 similar to 3. Can we look at those 2 statements you just proved to me? What else has to be similar then? 1 and 2 are both similar to 3, so 1 and 2 have to be similar to each other. You just found out all 3 triangles are similar to each other, which leads me to the final point. If they're all similar, be careful when you answer this. If all these 3 triangles are similar, what do I know about the sides that match up? Take it to the next level now. If the triangles are similar, what do I know about their sides? Taylor? They're all in the same ratio, right? They're all proportional. CSSTP. Oh. Here's the thing, though. If I tried to have you match up I'm not going to have you do it. Don't worry. But if I took triangle 1, let's see, triangle 1, and I said side BD, would you be able to match up the side that matches up with BD in triangle 3? Oh, boy. All right, BD matches up with what side in triangle? Ooh, that would be tough. All right, that would be tough. All right, maybe some of you could probably do it. Some of you might be guessing a side in triangle 3 that BD matches up with. The good news, I have 2 devices for you today that helps you match up these sides. All right, 2 devices that help you match up the sides. Before I introduce those, we're going to go over some vocabulary of all these sides. All right, some vocabulary. Let me start with side BC. Everyone see side BC in your diagram. What do we call that? That is the what of triangle BAC. Remember, we had our original right triangle up there. BC was called the what of that triangle. BC is the, let's talk here, Jackson, BC. That's the hypotenuse. So whenever we use the term hypotenuse moving forward, we're talking about the hypotenuse of the original right triangle. All right? Anybody know what the other 2 sides of a right triangle are called if it's not the hypotenuse? Legs. So we're going to refer to AC as a leg, and we're going to refer to BA as a leg. So when you hear the word leg, we're talking about the other 2 sides of the original right triangle. All right, there's a couple more things we need to label. How about AD? You should know the name for AD already. What is that? That's my altitude. So if you hear altitude, we're talking about this one right here. Altitude. Now there's 2 more pieces on this diagram I need your help with. Well, I'll tell you. Everyone see when I drew the altitude in, I split BC into two parts. The hypotenuse, they're not congruent, but I split it into two parts. Those two parts we're going to refer to as segments. Okay, we're going to refer to as segments. When you hear the word segment, it's one of the pieces the hypotenuse was broken up into. All right, so these are all the parts that are going to help you figure out what side matches up with what. So let me introduce you to one of my methods. Again, this is going to show you what side matches up with another side in one of the triangles. My first method is called SAS. Okay, my first method is called SAS. The letters form a proportion. Let's go over what each letter means now. S stands for one of the segments. Okay, whatever the segment length is, we plug in for this first S. All right, so this means segment. A. Well, there's only one thing up there that starts with A, right? And that would be the altitude. So whatever the altitude length is, we plug that in for A. Wait, now I got another A, but how many altitudes are labeled? So this is the same altitude. Same altitude. Whatever you plug in here better be plugged in there. Right? There's only one altitude in the diagram. And then finally, the last S stands for segment, and it's the other segment. All right, so we have both segments plugged into here. Whoa, notice anything from what we talked about the very first thing today in class? What are these in the proportion called again? Your extremes or your means? Means. This is a mean proportional. Because whatever you plug in for the altitude is going to be the same thing here. You should always be setting up mean proportionals. Whatever's in place of the mean should always be the same. So that's SAS. Segment over altitude equals altitude over other segment. Questions about that? Because sometimes that doesn't work. Or you don't have enough information. So you got to go to my second device. If SAS can't be used, we're going to try to use hills. Hills. Hills? I don't see an I. All right, relax. Okay, there is no I. See if you can help me here. H for hypotenuse. Yeah, whatever the hypotenuse is, that's what we're going to plug in. Hypotenuse length. L. Leg, one of the legs. Now, I know you asked which one, whatever one's being used in the problem. All right, so leg. All right, here we go. Here we go. Dig deep. What's that L stand for? Okay, you ready? Same leg after all the work we've done today. Same leg or a different leg? Same, because the means are always the same. It's going to be the same leg you put here, same value. And then, all right, now I got to do a little teaching here. S for segment, but I know right away people are going to be like, which one? Ready for the answer? It's always the segment next to the leg being used. It's the segment next to the leg being used. So if I go to my diagram, let's say we're using hills, and I plug in leg AC into my proportion. Leg AC. What segment would have to come next then? What's the segment next to AC? DC. All right, makes sense. So in hills, I plug in the segment next to the leg being used. Whew! That is a mouthful right there. Questions? Last thing before we start practicing. These are great little tricks to use, but you can only use them on this type of diagram. A right triangle with an altitude to the hypotenuse. It cannot be just used on two random similar triangles. Right triangle, altitude to the hypotenuse. All right, let's do this. I'm going to do 2 with you, and then you got 6 on your own, or with your group if you choose. Whew. All right, I'm going to take this slow. Sorry if it's too slow for some of you. First diagram. Does everybody see that right triangle ABC and altitude BD drawn down there? Okay, so I know I can use hills and SAS. What I didn't go over with you was, how do you know which one to pick? Right? Well, it depends on the information. In SAS, what does the A mean again? Remind me. What's A in SAS mean? Altitude. You guys see where the altitude is in the diagram up here? It's right here. Here's the altitude. Is that even labeled with a length or a variable? No, so why use SAS? You won't be able to plug anything into it. So the first thing I look at is the altitude involved? In this case, no, it's not. So there's no way I can use SAS. This is going to have to be a hills problem. All right, let's slowly go over what to plug in for each. And if you get something wrong, it's fine. First thing, what does the H represent in hills? What does the H represent there? Jesse, what's it represent? Hypotenuse. And remember, it's the hypotenuse of the original large right triangle. Do you know how long that hypotenuse is in this diagram, Jesse? 12. Thank you. So 12 is going to go in here. And let me show everyone because it's not automatic. Here's the hypotenuse, AC. And Jesse added 3 and 9. Okay, and that's where the 12 came from. L, what does the L stand for? Where am I going there? I'll get there. Maddie, what's the L stand for? Leg. And there's 2 of them in the diagram. There's AB and there is BC. You take the one you have information about. Maddie, which leg do I have information about? What is it? AB, which is Y. So I'm going to plug a Y there. There's the leg. Equals. That L is leg again, but remember, same leg, because the means have to be the same. So I put a Y here. You're darn right I'm going to be putting a Y here. Means are always the same, hills or SAS. And then finally, what's that last S mean to us? What's that last S mean here, T? Segment. Now look, I got 2 of them up here. I got 3 and I got 9. You don't choose which one. You choose the one adjacent to the leg we're using. So which segment, 3 or 9, is next to leg Y? Here we go. Going. I'll get you there. Keating? 3. And there it is. There's your proportion that matches up the corresponding sides. So cross multiply, you get Y squared. Cross multiply the extremes, you get 36. All right, now tell me why I don't want to go wrong here. I made a big deal earlier about, hey, you got to do plus or minus at the end, right? Well, not here. I don't want to do plus or minus here. Why not? Why am I not wanting to do plus or minus on this one? -6, does that make any sense? No, can't have a negative side length. You guys know that from last unit. Can't have a negative side length. So I'm just going to leave it as 6 because of the diagram. Questions? One more together here. Next diagram. Is the altitude involved? Is it labeled or do I have to find it? And the answer is yes, I need to find it. So now we're going to use SAS. S stands for? Jackson, S stands for? Pick one. Remember, segment is the 2 parts of the hypotenuse. 4. Yep, you could have started with 12, doesn't matter. A stands for? Juliana? Good talk. Should have known that. Again, 3 for 3. Nope, gonna have to come in handy here. Halo. Altitude? X, yep. And you say altitude again, it's the same altitude. There's only one in the diagram, X. And then what's this other S stand for? Ones, Jonathan? Segment. Again, it's in the extremes part, so it's got to be the other segment, which is how long, Jonathan? 12. Cross multiply. We get x squared. Extremes give me 48. And if no directions, and this goes for your homework tonight too, if no directions are stated, please leave it in simplest radical form from your calculator. I don't like decimals unless it actually says leave round it to the nearest whatever. And hopefully we're getting 4 square root of 3 there. Okay, you see those 6 below? On your own. See what you can do. Is it a Hills or a SAS problem? If it's leave your answers in simplest radical form if necessary. Bless you.
Thank you.
Call me over if you have a question with something. Ask your partners. It's up to you. But I'm going to give you guys a lot of time here to finish those 6. First, try to figure out what type of problem it is. Start as a group here soon, checking our answers. Just give people time to finish. All right, let's talk. Can everyone, I know you're starting the assignment, which is fine. Just go back to these 6 examples here for me. I'll do my best here calling 6 different people. Just give me the proportion you made. That's it. If you got the proportion, I'm assuming you got the correct answer. So, all right, let's start with the first one here. Give me your proportion, please. Let's start it off right. Lennon, your proportion? 6/4. That should have been a SAS one right there, right? X equals 9. Good so far. All right, next up, good start. Let me know what you got here. We're going 8. Jayla, what do you got for this one? Okay. Altitude involved. Is the altitude involved in this problem? So it's going to be a SAS, right? Okay, good. Make sure everyone, hey, sometimes it's not always, everything you need is not always given to you. You got to do some quick calculations, which is 10 over X and X over, what's that? 50 is the hypotenuse. You're doing SAS, right? 40. We okay here or no?
Yeah.
You sure? What?
I have the answer. I just didn't have the portion thing.
Okay, everyone good there? So we should have been X equals 20. Next up, C. Proportion for that one. Going, Izzy, what do you got?
25 over X equals X over 4.
Yep, again, I didn't give you the hypotenuse. You had to do a quick calculation of a 21 and 4 over X equals X over 4. Good work. And then X came out to be 10, correct? Yep, 10. Questions? Yeah, questions. And then D. Let's keep this train rolling. Hayden, what do you got for your proportion for D?
12 over X equals X over 3.
X over
3.
Okay, you're using X though, right?
Yep.
This S right here in Hill stands for the segment next to that leg.
So 9.
So it's got to be 9. All right, got to be 9. Everyone else, all right, a segment adjacent to it. Is that the 6 radical 3 one? Yep. So we end up with 6 radical 3. All right, next one up here. Boom, 5. Sydney's not here. Let's try this again. 13. I'll get to you. Just be patient. Like I don't. You should know these already. T proportion.
16 over X over X over 9.
There you go. That's SAS. Everyone should have SAS there. And then that one's a 12. And then for our final one over here, move that down. Let's finish this off right. We'll get there too. Jackson, proportion.
144 over X over 12.
Good. That's a SAS one. And then everyone should have 60 for that. 60. I will warn you, one of these you are going to have to factor tonight. So just a heads up there when you have an X squared in your problem. And then tomorrow we will do a day 2 of these. They get a little tough.